Okay, got one of these slightly harder differentiation questions involving, as you can see, fx here, which is the product of two separate functions. So it looks like we're going to be using the product rule, and we're probably going to be using the chain rule as well. But let's just go through the question and see what they want. Got a sketch of the curve. Okay, there's the function. X has got to be greater than 0. Cuts the x-axis in A and B and has a maximum turning point at Q. Find the x-coordinate of A and the x-coordinate of B. Well, so far that doesn't require any differentiation. Now, to find the points A and B, we need to set this guy to 0. So we get 8 minus x ln x equals 0. So if this to be true, therefore either ln x equals 0 or 8 minus x equals 0. Well, if the answer isn't obvious, take antilogs. The antilog of ln x is simply x, and the antilog of 0 is e to the 0. Anything to the power 0 is equal to 1. So we get x is equal to 1. And from the other equation, well, that's slightly easier. We get that x is equal to 8. And those are our two answers for part A, that x is equal to 8 and x is equal to 1. So we've got the points that A and B where the curve hits the axis. And we've earned ourselves 1 mark. Okay, now we've got to do a little bit more work to find the maximum point. Well, to find the maximum point, we need to differentiate the curve and then set that differential function, set that new function to 0 to find out where the gradient momentarily matches 0. And it looks like we're going to have to use the product rule. Okay, so let's set this up. We've got fx here at the top, and I'm going to call this bit of the function u and this v. And the product rule states that dy dx equals u dv plus v du. So we need the differential of both of these guys. So let's set up a table. So u is equal to 8 minus x, and v is equal to ln x. The differential of u, du dx, is -1. And dv dx is 1 over x. So we've got all the constituent parts of our product rule formula, so I can say that dy dx, which in this case is f prime x, is equal to u dv, u, 8 minus x, dv over x, plus v ln x du -1. Just going to put that in a bracket and sort that out later. So simplifying a tiny bit, we get 8 minus x over x minus ln x. So coming over here at the TP, at the turning point, f prime x, our differential function, equals 0. Therefore, we get that 8 minus x over x is equal to ln x. Let's multiply across by x, and I get that 8 minus x is equal to x ln x. And therefore, I get that 8 is equal to x ln x plus x. And that is equal, if I take the factor of x out, is ln x plus 1. So on the next line, I can say that x is equal to 8 over 1 plus ln x. And that's the answer they required.